Hey everyone, so today we're going to go over how to find the greatest common factor. Now for the first problem, I'm going to ask you to find the greatest common factor of 21 and 28. Now the steps to doing this are pretty simple. First, we just want to find all the factors of 21 and 28. Now, apart from that number multiplied by itself. So for 21, we have 7 times 3, and that's also the prime factorization of 21. And for 28, we have 7 times 4. But we can break that down. We can break 7 times 4 into 7 times 2 times 2. Because our goal is to find the prime factorization. So these two are both prime factorization. Now that we know the prime factorization for 21 and 28, we see which factors are common. As you can tell, the 7 for both, the 7 is found in both of them. So the GCF for 21 and 28 is equal to 7. Let's try another example. Let's go 33 and 77. Now, if you feel like you can do this on your own, try to do it on your own. Pause the video and then come back. But to do this, we follow the same process. The prime factorization for 33 is equal to 11 times 3. And then for 77, it's equal to 11 times 7. And that's because 11 and 3 and 11 and 7 are both prime numbers. So that's the prime factorization. And then which factors are common? Well, obviously the 11 is found in both. So the GCF is equal to 11. Let's try another example. Let's do 15 and 18. Now find the factors for both of these. So for 15, you have 5. You have 5 times 3. That's your prime factorization. And then for 18, you have 6 times 3, which is broken down into 3 times 2 times 3. So now this and that is your prime factorization. And then we'll find the common factors, and the common factors of 5 and 3 and 3, 2, 3 is 3. So the GCF is equal to 3. Let's try a different type of problem. Let's do 6x. I want you to find the greatest common factor for 6x and 9x squared. So it's the same process. Now we find the factors for 6x, which will give us 3, 2, and x. And then, let me write it as a multiplication statement. 3 times 2 times x times, 3 times 2 times x. And then for 9x squared, you have 3 times 3 times x times x. So now, what is the GCF? Well, which factors are common? Well, we have a 3 in both of them, and then we have an x in both of them. So the GCF is equal to 3x. Let's try another example. Let's do 24 x squared y squared and 30 x to the 4 y to the 6. Now feel free to try this on your own, but once again, we follow the exact same process. 24x squared y squared is equal to, sorry about that, 24x squared y squared is equal to 6 times 4, which is really equal to 3 times 2 times 2 times 2. 3 times 2 times 2 times 2. That gives us 24. Times 2 is 6. Times 2 is 12. Times 2 is 24. And then you get x times x and y times y. And then 30x to the 4y to the 6. Whoops. 30x to the 4y to the 6 is 3 times 2 times 5. That gives us 30. And then you have to multiply 4 x's and then 6 y's. And so now the GCF, when you find which common terms you have in each, you have a 3 in each and you have a 2 in each. So that will give you 6. GCF is equal to 6. And then you have 2 x's in each, x squared, and then you have 2 y's in each, y squared. And that's your GCF. So you just have to lay it all out and then see which terms you are found in both. Let's try one more. Let's do, find the GCF for 12, 18, and 21. Now you can do the prime factorization ways I showed you above, or you can just list all the terms or all the factors for each, including the number times itself, if that's more like more simple for you. But I'll show that way because I haven't yet. So you can go 12, 18, and 21. And for 12, you have 1 times 12. You have 2 times 6. And then you have 3 times 4. And for 18, you have 1 times 18. You have 2 times 9. You have 3 times 6. And then for 21, you have 1 times 21. And you have 7 times 3. And so now when you're looking at all three and you're looking for which number is found in all three of them, and you can't have 1 be that number, 2 isn't found in all three, well, it's easier just to look at the one with the smallest factors and then to work backwards. So 7 found in all three? Nope. Is 3 found in all three? Yep. And so your greatest common factor, your GCF, is equal to 3. Now let's try one more example. Same stylistic question. Let's go 30, 56, and 64. And let's do this the way I just showed you. So let's write out all the factors for each. And 64. Okay, so you have 1 and 30. You have 2 and 15. You have 3 and 10. You have 5 and 6. I believe that's all the factors of 30. For 56, you have 1 and 56. You have 2 and 23. Oh, sorry, nope. I lied, that's not 56. That would be 2 and 28. You have 4 and 14. And then you have 7 times 8. And then for 64, you have 1 and 64. You have 2 and 32. You have 4 and 16. And then you have 8 times 8. Now, which number is found in all three? And this This might take some time just to go through all three and find to check. But 2 is the number found in all three. And so your GCF is equal to 2.